Okay, so before we introduce other ways to solve the XOR problem, I need to do another detour here, because so far we've only looked at like training data, and as many people are familiar here, there's something called overfit. For example, if I have n points, I can always use a polynomial of degree n-1 and draw a curve that crosses all the points. Yeah, is that a good predictor for like more data from the same distribution? Most likely no. Yeah, that's clearly overfitting. I'm just that's just a different way to describe the original data. I could just give you a list of points, and it would be the same. So in the context of neural network training, the way I deal with this is I set aside some of the data as validation data. And here, just to show that they can also come from like slightly different strs, I'm taking the validation data from the same distribution of the training data, but with a slightly larger domain to see how my model performs on out of distribution data. And okay, so let's use my my trick so far. So this was my this F here. Oh yeah, okay, perfect. Yeah, this is my function still that I defined, and using the red points, let's do a training. So in this case, I'm not doing any fancy. I'm just using a simple code. But in this case, I apply a rule here to my training data, and I apply a rule to my validation data, and you see that we are going down to the training data, we are going down to the validation data. And I'm better on the training because there's some off distribution here. But if I wait a bit, you see that no, okay, in this case, this is particularly simple because I encoded things correctly. So it's very difficult to overfit here because I'm doing a linear combination. So in this case, my model is well parameterized and is not overfitting. Why I'm talking about overfitting, looking at these two curves, because a very simple way to make sure you're not overfitting is to check that the this blue validation curve is going down together with the orange training curve. Yeah, this I can always if my model is powerful enough, I can always bring my orange curve down by learning the data. I want to make sure that on new data, like unrelated data, I'm still performing correctly. So now this is my okay. This was static. I could have stopped it before, but you see now the final result is that I have learned. I kind of knew. This I was kind of cheating because I created I encoded the input in a way that could completely correctly describe the distribution. And you see that this has learned correctly. I mean, what it did was to learn correctly the coefficients of a linear combination. Okay, so this is one way. It works if you have knowledge about the word. This is do not discount this, because it's much easier to train and to make it converge than the more complex thing that I'm going to show now.